That's why in a lot of these sample systems, we can have issues in the pump where we have it nowhere else. And people will say, oh my goodness, I'm not filtering things properly at the probe. My pump's getting all plugged up. And really what it is it's that chemical salt forming. Why would it form in the pump? Why? What's magical about the pump? It's the chemistry behind all this. I need to take that hot, wet gas coming out of your stack, whether it is steel mill, cement plant, pharmaceutical, oxidizer, incinerator, whatever your application. You're going to take that gas that you would never stick your hand or your head into to look at, and you're now going to bring that out and put it into an analyzer. Whether it's extractive, in situ, doesn't really matter. And what affects the chemistry? You know, we talk about chemistry being affected by time, temperature, and we say agitation of movement. So the best example I often give in training courses is, you know, I'll have my hot coffee here, and I'll take a little bit of sugar, and I'll dump it in. And it'll be a glass, you know, a see-through glass coffee cup. So we see the sugar slowly trickle to the bottom. You can still see some of the granules there. Some of it's dissolved, some of it's still there. I take the spoon, give a little stir, it's all gone. I now do the exact same thing with a glass of sweet tea, or in this case, iced tea, unsweetened. And we've all had it. We've been down south, we decided to get some iced tea. I like iced tea. So sometimes the waitress comes over and she brings you unsweetened tea. So you're like, okay, you reach for the packet, you pull it out, you open it up, you dump one in, you dump two in, and you see some of it hits the ice cubes and it, you know, kind of sits there, does nothing. Some of it actually makes it to the bottom. But you can see it through the glass. You can see it sitting on the bottom. So all it's do the same thing. We grab the spoon, we give it a stir, there it is. Now it all just sinks to the bottom again. What the heck, what's going on? Stir it again. So you create the agitation, but it's cold. Things don't dissolve the same way in the cold as they do in the hot. So we differentiate hot coffee from cold tea and just the way sugar works. So in every application, you have temperature makes a big difference. Whether you actually cause a chemical salt to form or dissolve, something to knock out or to pass through as a gas. And then we talk about agitation, the movement. Well, I mean, it's a sample gas. Who's mixing? No one does, but realize what we have. We have pressure from the stack, which is a force. We have your pump, for those that use piston-style pumps. You have a negative and positive stroke of a piston-style pump. That creates pressure, expansion, contraction. So, long story short, whenever we talk about this kind of stuff, the front-end conditioning has so much to do with how well your analyzer is going to work,